the last exercise is again more complicated. The wording is also maybe a little bit fake. So we are asked to search for a given zero terminated substring in a string returns 1 if it's present and 0 if not. So a substring function. We have to define the string in a data section, place the result in A0. Now, this might be confusing, so first write a solution assuming that the characters of the string are 32-bit words. Use .word instead of .string. And then we ask what changes when the characters are bytes. So in terms of what we mean by this, or what we intended by this, but it has caused some confusion, is that we just write our string as an array of numbers. And then we see if there is, but we do zero terminated, so that we don't need to worry about sizes. And this is so that it's the same approach as when we're using strings. So we basically have a zero terminated array here of integers, which you could interpret as a string. That's how a string works. So we have our string here and our substring. And the reason we did it like this is because it's a little bit easier to first work with full words and then afterwards convert the solution to work with bytes instead of words, since characters will be 1 byte size and not 4 byte in size. But the solution is a little bit more simple if you just work directly with words. Okay, so let me first, on an abstract level, explain how this solution will work. So the solution will work based on 2 pointers. You will have a pointer that goes through this entire array and goes through each element. And at each element, it will pause and it will check, is there a substring at this position? How will it do that? So that's the outer loop. The outer loop will go over each element of the substring and check if this substring can fit right there. How can it do that? Well, that's why we use a second pointer. We have a second pointer, and that's pointing to the substring. And it's going to point initially to the first element of the substring. First thing you check are these pointers pointing to the same value? Right now, when we're going to the first element of the array, obviously not, because 1 is not equal to 2. That means you can't have a substring right here, so you can advance the main pointer by 1. Let's say we would be in the second position here. The main pointer, the outer loop, has advanced. We already know there's no substring in position 1. There might be one in position 2. The pointer of the substring is still pointing to the first element. Now, we check here. Is this equal? Is the outer loop pointer and the substring pointer, are the values equal? Are they pointing to the same value? If so, it's possible that there's a substring right here. And then what we do, if it's possible that there's a substring, then we will advance both pointers by 1 word. So right here. And we will keep on doing this, advancing by 1 word, as long as these values are equal. If this were a value 4, we would stop. But since it's 3, we advance again. And as long as the values are equal, we can advance. If they are not equal, so if we reach the null byte in the substring, before we have quit this procedure, then that means we have found a substring, because that's the end of the substring. We had all matching results. So once we reach the null byte of the substring, and everything before that was matching, then you have a valid substring. So you will check each time. In the inner loop, you will try to increment both pointers by 1, but you will only do this if the values of both pointers are equal, and if the substring is not pointing to the null byte. That's the general procedure. If you can never complete this, if you never reach the null byte in the substring, and before you reach the null byte in the string, then you know there is no substring, and you return 0. Now let's see how we implemented this. T0 is going to be the string pointer, T1 is going to be the substring pointer, T2 is going to be, so whenever we're going into the inner loop, we're going to advance both pointers by 1. We also need, whenever we have a failure here, we need to jump back in the main string, jump back to where we were. Right? If we advance 3 times here and it was a fail, not a match, then we have to jump back so we can check the next element. So that's why we use T3. T3 and T2 will be the both pointers that advance in the inner loop, while T1 will simply advance in the outer loop over each element. Then T4 will always hold, T3 will always hold the dereference of the pointer in the string, and T4 will hold the dereference of the pointer in the substring, so the actual character at that location. And that's basically it. How will we implement this? So every loop in the inner loop, first we reset so that T2, the pointer for the string for the inner loop, points to T0, the pointer for the outer loop. The outer loop, as you can see, it will just advance T1 by 1 each time. Oh, sorry, here. It will advance, T0 is the pointer to the outer string. So T0 is advanced by 1 word each iteration of the outer loop, and then that's continued. And then in the inner loop, that's where the magic happens. First of all, you make sure that T2, at the start of one of those inner loop procedures, T2 has to point to where we are currently in the main string. And then we will be checking the values of T2 and T1 of both pointers. So first, this will be here. In the second iteration of the outer loop, we will be checking these two values. So we dereference T2 and T1, both pointers, the pointer to the substring and the pointer to the string. These values are now, these characters are in T3 and T4, and we will then need to compare them. So we compare them right here, and if they are equal, if T4 was equal to 0, if we have reached the end of the substring, that means we successfully found the substring, and we can jump to the success condition, which returns 1. That's what the case when we reach the 0 byte, the null byte in the substring. If not, we want to continue with our inner loop. And in our inner loop, every time after dereferencing the pointers, we can already advance them by 4 to point to the next word. So that when we execute the inner loop again, we load the next characters. So this keeps on repeating. These instructions, this inner loop keeps on repeating and repeating as long as we have matching characters. If we don't have matching characters, then we go to this and we advance the pointer in the outer loop. So we go and check the next position in the array. That's what happens right here. Right here. And then we do the outer loop. Once we finish the outer loop, we checked every position of the array and nowhere was a valid substring found. We reached the null byte in the main array. That's so when do we check this? So in the outer loop, this is where we, if T3, the pointer in the array, is pointing to the null byte, we've reached the end of the string and we didn't reach a substring. So at that point, you can jump, you can skip going to the next element, you're done. And you could just say we haven't found a substring, we move the 0 result to the return value register A0, and we jump to the end of the program. Now, in the second part, we are asked to do this now, but with actual strings. Now, this will be exactly the same program. I'll open 7.2. Exactly the same program. We now have string and substring as actual strings. But the only difference now is that each char is now represented as 1 byte instead of 4 bytes. So we have to use load byte right here instead of load word, because every string character is a byte, another word. And then we have to increment by 1 the address of the pointer instead of incrementing the address of the pointer by 4. That's the big difference, because we're jumping 1 byte instead of jumping 1 word. But for the rest, these are exactly the same. And that's how you could do a substring search. And if you've reached so far in the exercise session and you managed to solve this one, you should have most of the initial syntax of RISC-V under your belt, and you are prepared for the next exercise session in which we will learn functions. See you then.